Okay, hi guys. Today we are looking at double number lines. Double number lines, like ratio tables and tape diagrams, are another way that we can show equivalent ratios. Today we're going to build our double number lines starting with ratio tables, and then we can build our double number lines from there. So, our question is, at Kat's Bakery, you can get 3 cupcakes for $5. So we want to make a ratio table using the given ratios so that we can find equivalent ratios here with the cupcakes and the dollars as our ratio. So we have cupcakes and dollars, and we're going to make a ratio table. And we've got 3 cupcakes for $5. And I think, so looking at the cupcakes, we're going to go up by 3s. So we have 3, 6, 9, 12, 15. Got one more in there, 18. And then our dollars are going to go up by 5. So 5, 10, 15, 20, 25, and 30. So that's our ratio table of our ratio. And so now we have all these equivalent ratios. We have 3 to 5, and 6 to 10, and 9 to 15. And you can see all of these sets of equivalent ratios here. Now when we do a double number line, this is very similar. We still label things cupcakes and dollars. So I'm going to label cupcakes and dollars. And I'm going to draw a number line going to the right from each of the labels. So I'm going to have 2 lines that are on top of each other. One represents the number of cupcakes and one represents the number of dollars. And as I set this up, I'm just going to be setting up, first of all, I'm going to draw a line here. That kind of says, all right, well, if you bought 0 cupcakes, it's going to cost you $0. But then I'm going to set another line going through both of these double number lines. And this is going to represent the 3 cupcakes for $5. And then I'll have 6 cupcakes and $10, and 9 cupcakes and $15. And notice how I'm just getting my information straight out of my ratio table that I built above. So as you're doing your work today, you're going to build both a ratio table and a double number line so that you can show how your ratios fit on both of how your equivalent ratios can be represented with both of these systems. So that's my double number line. And notice that my cupcakes are on the top line and my dollars are on the bottom line. And the lines that go vertically are representing the equivalent ratios. All right, with that double number line then, if I had $32, I would like to know how many cupcakes I could buy. So going back, I had my cupcakes and I had my dollars and my double number line. And I want to know, well, if I had $32, how many cupcakes would I be able to buy? So I know it was 3 for $5 and 6, 9. Oh, that was 10, sorry. The 9 goes up on top here. And I'm getting closer. I'm at $25 down there on the bottom. And now I'm up to 30. So I know if I had $30, I could get 18 cupcakes. If I go another 3 cupcakes, this is where I'm going to look and I'm going to say, well, listen, I know it's going to be somewhere between 18 and 21 cupcakes that I could buy. And so with a double number line, what I can do is I can say, well, up on top, I've got in between 18 and 21, I've got 19 and 20 cupcakes. But in between, down on the bottom line, in between $30 and $35, we've got $31, $32, $33, and $34. So my question is, if this dot down on the bottom represents $32, let's see if I can sneak this in here, $32, where is that going to cross my double number line? On the top. And if I go straight up, if I go straight up from there, I'm going to end up at about 19 cupcakes. So I can say that if I had $32, I could buy 19 cupcakes. Because my $32 down here, when I bring my line straight up, it's going to cross at 19 cupcakes. Here's another question using the same idea. I have a party coming up and I'm going to need 25 cupcakes. So how much will they cost? So thinking about my double number line, remember I had cupcakes and dollars. And I don't think I want to redraw this whole thing. So I'm just going to go back and look. Where am I getting close to? Up here, I've got 21 and 35. Looking at this last little bit here, and I'll circle that in green. This last equivalent ratio was 21 and 35. So when I look at this, I think I'm going to build my double number line, starting with 21 and $35. Remember, our original ratio had us going up by 3s and 5s. So as I go up then, I can do 21 plus 3 would be 24. That's close, but I need 25. So I think I'm going to have to go another equivalent ratio here, which would get me to 27. And down on the bottom, if I'm going by $5, this would be $40, and this would be $45. So I'm looking for this spot up here. It's going to be in between those two. So remember, I want 25 cupcakes. So I look on the top line, which tells me my cupcakes. And I know between 24 and 27, I've got 25 and 26. So I'm looking right here at 25 cupcakes. And down on the bottom, remember, we're going by 5s. So I've got 41, 42, 43, 44, and $45. So if I were to cross this line here, go straight down and see where it crosses, it's going to cross at about $42. So how much money is it going to cost to get 25 cupcakes? About $42. So that's how we use double number lines. We can show our equivalent ratios, and then we can try to find those parts that are in between so we can make a really good estimate of how much money it's going to cost us when those ratios don't quite match up with what we have in our ratio tables. All right, so we have Cherie. Cherie solves 3 math problems in 4 minutes. And so if we're looking at that, we have 3 math problems in 4 minutes. So we've got the number of problems and the number of minutes. And I'm just going to abbreviate both of those. So remember, I'm efficient. And I'm going to create this ratio table. And we said we could do 3 math problems in 4 minutes. So as I'm creating this ratio table, my problems are going to go up by 3 on the top. And on the bottom, we're going to go up by 4s. So there's my ratio table. It goes with this ratio 3 to 4. So we've just built a ratio table of equivalent ratios, ratios that are equivalent to 3 to 4, because that was our original ratio that they gave us. Okay, so using this ratio table, we can go on and look at the rest of the problem here. And it says, oh, listen, Cherie has soccer practice on Thursday evening. She has half an hour before practice to work on her math homework and to talk to her friends. She has 20 problems or 20 math skill work questions for homework, so 20 problems, and she wants to complete them before talking with her friends. How many minutes will Cherie have left after completing her math homework to talk to her friends? So we know that she has half an hour, which is also what? 30 minutes of time, because half an hour is 30 minutes. And we also know that she has 20 problems that she has to do. So let's go back and look at our ratio table for a second. If I follow my problems along, 20 problems are going to fall in here between 18 and 21 problems. So it looks like she's going to have enough time, because if we look down at the bottom, it says it's going to take her between 24 and 28 minutes to do this. So if we're looking at building a ratio, equivalent ratio double number line here from this ratio table, I'm actually just going to do the circled part. So I'm going to do problems in minutes. I'm going to draw a double number line, 2 lines going out to the right. And I'm going to start with this first ratio that is encircled, is 18 to 24. And then I'm going to do the second one, 21 to 28. Well, we know she has 20 problems, so up on the top line is our problems. So we've got 18, 19, 20. This is how many problems she has to finish. And then looking down here on the bottom in the minutes, I'll do that in purple. In the minutes, we've got 24, and we need to fit in 25, 26, 27 in the middle there. So we got 25, 26, and 27. So our 20 problems up on top comes out here, and it gets about halfway between 26 and 27. So we're going to say 26 and a half minutes to do her work. Well, going back to the problem, we had 30 minutes, and we're going to subtract those 26 and a half minutes. And so we're going to end up with 3.5 minutes for her to talk to her friends after she finishes her homework. Okay, so today you're working on double number lines and how they work with ratio tables. So in your practice today, you're going to be doing both ratio tables and double number lines.